I need to install this update on my iPad. I don't have my charger. I have no way to convert AC to DC power. I can't charge it. It sucks. Stupid iPad. Stupid life.
So American having some problems with AC DC power. Have you tried using that project we made in Mehods recently?
You mean this project?
Of course, that project. The purpose of this circuit is to convert AC voltage to DC voltage. So you have an AC source right here. It comes into a junction between two diodes, and the other end comes into a junction of two more diodes. These will create a voltage flow that the AC would look like that, but this creates a voltage of this. This is called dirty DC voltage. We're going to take that dirty DC voltage and run it through a current limiting resistor and into an array of LEDs. So, on the actual circuit, we have our 4 diodes, our current limiting resistor, our connectors to our AC power source, and our LED array.
And our capacitor.
The purpose of the capacitor, which is 470 microfarads in this case, is to steady out this dirty DC. It makes it smoother, which creates a more constant voltage. This is not required, but it makes it look a little bit better. When you hook everything up, the lights should be powered as if they were hooked up to a DC source.
Well, actually, a clean DC voltage is one in which the voltage doesn't change with time, right? So specifically, if you plot voltage against time, you should see a flat line. That means a dirty DC voltage contains some amount of ripple, which we called harmonic distortion, right? So when plotted against time, a dirty DC voltage shows a rippled line, in which the ripples are due to small AC artifacts called harmonics. Yep. Because these harmonics distort that flat line, the dirty DC voltage is said to suffer from harmonics distortion. When used in lighting, however, we cannot see this distortion, and the LEDs are not bothered by them. Yeah.
The correct output for our dirty DC voltage converter, we have to use a waveform generator, and what we're going to do is set it to sine wave, make sure that it's on 60 Hertz. And then we're going to set our amplitude to 10 VPP.
Keep in mind that when you're dealing with AC voltage converted to DC voltage, you're not going to get the VPP you put out.
Why?
Because you're going to get the root mean square. VRMS is defined as voltage peak to peak over the square root of 2. In this case, we're going to have 10 volts over the square root of 2, which will equal 7.07 volts. This will be
RMS voltage?
This equals VRMS, yes. And this will be the voltage that our DC circuit sees, not 10 volts.
On. And then we take our 2 output connectors, black, we have our voltage converter.
Bring the thunder.